So in this video, we're going to see a graph theory 2 marks question from the year GATE 2017, and the topic is degrees of vertices. So let's see what the question is. G is an undirected graph with n vertices and 25 edges such that each vertex has a degree at least 3. Okay, then the maximum possible value of n is, and we are given 4 options. So first, let's quickly make a note of the information that has been given to us. So our graph G is a graph and it has n vertices, which is unknown, we don't know what is the value of n, and it has 25 edges. So the total number of edges are 25, and very important, every vertex has a degree of at least 3. Okay, so degree of each vertex starts from 3. So at least 3. So it could be 3, it could be 4, it could be 5, and so on. Okay, minimum is 3. Now we have to find the maximum possible value of n. What is the maximum possible value of n? Okay, and we are given these 4 options. Now let's try to use the elimination strategy, where we take each option from each value of the option and we try to see if it fits into the question that we're trying to solve. So let's start with option D first, 24. Now if n is equal to 24, it means I will have 24 vertices. So just imagine I have 24 vertices here. Okay, the 24, and now I have to fit in 25 edges. So most of my edges will go in fitting every vertex one by one, and as you can see that this property, that the degree of each vertex should be minimum 3, won't be satisfied. So if I take n is equal to 24, then I won't be able to satisfy this property, because most of them will have a degree as equal to 2. Here you can see degrees 2, degrees 2, degrees 2. So n is equal to 24 is going to be a incorrect option. Now let's go with a is equal to 4. Okay, the first option. Before that, let me just clear this. Okay, now let the number of vertices be equal to 4. So let's draw these 4 vertices here. Here I have them, and now again note we have 25 edges to satisfy. So I will have to first connect these 4 like this, then I have to connect them like this, like this, like this, then I have to again connect them like this, like this, like this, like this. So I have to do a multiple connections between these 4 vertices because I have 25 edges to cover. So definitely 4 is not going to be the maximum. 4 is not going to be the maximum possible value of n. So 4 also goes out of competition. Now let's see if 8 can work. Now we just have 2 values, 8 and 16. Let's see which one of them can follow the question. Let me clear this. Okay, now B8. So let me draw 8. 1, 2, 3, 4, 5, 6, 7, 8. These are my 8 vertices. Now again, you have to remember that there are 25 edges we have to put in. So let's try to put the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have put 13 edges. Okay, we have to also satisfy this property. So it is satisfied here, it is not satisfied here. Okay, I'll put one more. So 14 edges are gone. So 3 degrees, at least 3, at least 3, at least 3. Okay, this one is remaining. So 14 edges had gone. So this is again my 15th edge, and I can put one more like this, and so 15, 16. So still we have 25 edges to cover, which means that we can add more vertices and still, you know, get still try to cover this 25 number of edges by adding more and more vertices. So 8 is definitely not the maximum possible value of n. Okay, so so option B, 8, also goes out of competition. So thus we have used the elimination strategy. We have done a little bit of cheating here, but that's okay, because there are certain questions in GATE examination where you should actually use the elimination strategy and try to eliminate the options, and then finally come to one option which might be a right answer. So here option C is going to be our right answer.